EE World, I'm Martin Rowe. We are at APEC 2025 in Atlanta. We're in the Tektronix booth, and Bill Driver is going to describe this new current probe. It uses a different technology than what you'd expect from a current probe. So Bill, why don't you tell us about it?
Sure, Barton. Happy to. Yeah, hi, this is the Tektronix TICP. It's the isolated current probe that we just released a few months ago, actually. And so what's exciting about this is our third generation in isolation technology. So the previous two were using optical isolation. That gives us extremely high common mode dejection and common mode voltage. This technique is using RF isolation. And so we're using a transmitter receiver and an isolation transformer to transfer power to the isolation side. So the body is long because we have our isolation barrier within this body.
Okay.
And we name it the TICP as an isolated current probe, even though it is a differential voltage probe. The intent was to measure really precise current with really low noise across a shunt, hence the name current probe, even though it is a differential voltage probe.
Okay.
So the combination of the RF isolation, it is a 50 ohm path, and then we're just hooked up to a demo board here, but this will measure extremely low current. This is our 1x tip with a dynamic range of plus or minus half a volt. And in this example, we found an extremely low noise, even as a voltage probe, but for current, it's beating our Hall effect probe and our Rogowski probe.
So you've got, I'm going to assume what you've got is some sort of transmitter and receiver inside of this, this case.
Yes.
Okay. And I assume you're modulating modulating a carrier based on what you're measuring over there.
Correct, yes.
Okay.
It's kind of up converted and back down. That's how it's transmitting. With shielding, obviously it's not emitting that out. And so that's a pretty efficient way to transfer the information and to power the isolation barrier. And one thing just to mention, so the bandwidth's up to 1 gigahertz on this, which is going to be limited by your shunt, but 3 models, 250 megahertz, 500 megahertz, and a gigahertz with extremely high common mode rejection.